The broadcast is now starting. All attendees are in listen-only mode.
All right, good afternoon, everyone, and welcome to the last webinar for today. This is the last webinar of TopSolid'Cam improvements for 2021. Tomorrow's morning, we'll have two more webinars to deal with split and mold and strip design for progressive dies. Okay, so this afternoon's final webinar, we are going to be going over some miscellaneous things, such as improvements to methods. We're going to talk about a machinability property. We're going to show you how to apply the global fitting new surfacing command and use it within machining. And then a few other things such as the Mako Interface and machine preview and position changes. So let's get started. So with methods, and actually this one I think I can show live. Some of them I'll show live, some I'll show with videos. One of the first improvements here is within the analysis of drillings and cylinders when we use the menu create hole stack method. And what does that mean? So if I go into my analysis tools, let it fire up here. Notice that a couple of my drillings have different colors to them. If we look in the associations here, you'll see these are grouped by a method, blue and yellow. And you see blue and yellow there. The way that method was created was by selecting the group of drillings, by selecting one of the drillings and right-clicking and then choosing create hole stack method. When you do that, it's going to set up a new method for you based on the drillings that are there. The first thing that you'll notice is there is two cylindrical body searches. One is blue for the counterbore and yellow for the drilling. And then it also sets up the basic drilling methods for you as well. So then you can set these up also. Once that has been created, whenever you go and run your drilling analysis and holes of these colors show up, it will auto pick that methodology for you. Okie doke. In general, methods with colors is another point here. I'm going to bring this over because I don't think we need to do it again. In general method, you also have the ability to use visualization colors to identify stuff. Okay? It's not mandatory, but it is available. Okay, select a tool in magazine. Let's go ahead and take a look at this thing. For those of you familiar with creating methods, one of the improvements here has to do with inside the function select a tool. You had the question choose tool only in document. Okay, so here you see this, and when we have this selected, there are four possible outcomes. We have if that's set to always and tool is set to manual selection down here. Okay, in this case, TopSolid will open the tool manager and will show only tools that respect the conditions allowed tool types. Okay, so here you have allowed tool types. And here, let me open this up right quick. So if we're on, always and manual selection. So if we're on always and manual selection, it's going to, when you execute this method, it's going to bring up your list of tools and it will search for tools that you have set in here. So if my allowed tool types are, for example, spot drills and twist drills, it will only show tools that are in my carousel that are of type spot drill and twist drill. From there, you have case number 2, where choose tool and document is set to always and tool is equal to a given tool. In this case, it will choose the tool, the given tool, if it's present in the machine. So if I switch this from manual selection to given tool, and then I go into here, I can go choose a specific 12mm drill, okay? And if it sees that drill specifically loaded in a pocket in my carousel, it will select it. The third case is, again, if choose tool only in document is set to always, and tool equals manual selection with filter. Only tools that respect the given filter will be displayed. Let me bring this over here. In a case like that, if you're using it with a specific filter, once you set the filter, when you're executing the method, you can apply the method tool filter, okay? You can either activate or deactivate that filter to show more tools, okay? And then choose tool only in document equals always, and tool equals filter is the fourth case. And TopSolid will select the first tool that respects the filters. Perfect. I can show you this really quick, give you an idea of how it runs. All right, so this is showing you the type of tools we have here: spotting drill, center drill, spotting drill, right? I'm just going to fast forward some of this. Again, right now it's set to always and manual selection. And now when we go and execute this, it brings up the tool list because it's a manual selection, waiting for you to select which spotting drill you want to run. We go and do this again, but let's set this to a given tool. Again, I'll fast forward some of this. So there, I specified a specific tool. And then when we go and execute this method, I'm picking my drilling and no tool pops up because it's going to apply a specific tool, right? Third is filter. So manual selection with a filter. And now when we go and select, it's going to filter and based on the filter rules, show me the tools that are available. And again, you can deselect the method tool filter so you see all your tools. And then the last one is just with a filter. Okay? Perfect. All right. Next one has to do with manufacturing features and multi-holes, multi-stepped holes. So it's easier to describe here. So when we have a multi-step drilling like this, the order in which the drilling was designed is the order in which these features need to be created here. Okay, so from top to bottom, 1, 2, 3, 4. Same thing, 1, 2, 3, 4. All right, so this is again for manufacturing feature recognition. So if I go and quickly run through that video, again, just pointing out that the order in which things are done. So you have the 2 counterbores first, then you have the 2 drillings. Here is a spot facing, that's spot facing number 1, spot facing number 2, then drilling number 1, drilling number 2, and so on. And then this way, when you go to execute the method or the machinable method, you specify which process, you hit go, and it just applies everything automatically. Okay, perfect. All right, the next one is pretty cool. It is an improvement to copying and pasting operations in the same document. Again, there's a lot of content, so I'm going to go through videos for probably most of these. So here I'm copying all the operations from the main spindle, and then let me back up for a second here. And then if you notice, well, here, I'll go back to the video in a sec. So if I copy everything, then you see here a new option called paste graphically. Okay. So with paste graphically, what's going to happen is it's now going to execute a temporary method for you to apply all those geometries. What's interesting though is if you choose to not apply a specific portion of the method, just hit next without selecting anything. It's going to ask you that question, do you really want to stop executing? You hit no. And what it does is it puts a copy of that operation in, but it's disabled. Just in case you weren't ready to select the geometry for one reason or another, you wanted to just copy it over, but disable it so that you can decide to use it in the future or not. And I'll show a sample of that here in just a second. So here we're applying everything. It's calculating. And then about the only thing you need to do is, if it's a B-axis machine, for example, is go through and change tool orientations, but the operation settings are all there. So you have some work to do, but for the most part, everything else is copied over beautifully. And you can just quickly go in, apply everything, and off you go. The next one has to do with copy and paste of operations without selecting geometry. And this will showcase a pretty interesting aspect of this new improvement. So again, we have some features, right? We have two different cam files. Could be in the same cam file, doesn't really matter. So we're going to copy these four operations, right? So let's select them. We'll right click, we'll choose copy. We'll go and activate the other cam file. And then we'll go into the operations manager, paste. And from there, we're going to start selecting geometries. This next one's for the side milling, perfect. This next one's for chamfering. I don't know what profiles or edges I want to use yet, so I'm just going to hit the blue arrow for next. And then here, do you really want to stop picking? If I hit yes, it stops the execution of all this completely. If I click no, it just creates that empty operation and deactivates it for me for later use. Maybe we'll do that again on this slot machining just to show you. So here I'm going to hit yes to stop executing at this point. So now it's applying those operations. And if you notice, two of the operations came in calculated, two of them came in grayed out. So now we can choose if we want to activate one of these operations, for example, the slot milling. We can right click on that and we can go and activate that operation, decide to use it after all. So it has no geometry selected, so let's go select our geometry. And then you're done. Perfect. Okay, this next improvement is having to do with the machining pocket. Okay, so let's go grab this one. And this has to do with like holders like this, where you can have one or two, three or four different pockets available on the holder. So here in this method, we're doing a search, finding each of the tooling pockets. Okay. And then within the operation itself, we're telling it that for this operation, use the results of whatever tool was found in machining pocket 2. And then like that, it'll apply the tool path using that specific pocket. Okay, another interesting one has to do with default values. So I'm going to pause that just for a second and just kind of talk here. So there's default values in TopSolid'Cam, we all know that. What this improvement is for is whether or not and how you want to use default values on top of your methodologies. Okay, So we'll let this start playing as I describe. So here we have some operations. Okay, so the operations have some stock to leave. And basically what's going to happen here is this. If we go and look at our default operations or default values, we'll go to our milling module, we'll go to side milling. Let's go look to stock to leave. So the stock to leave value on the wall is currently 0 by default. Okay. Now, if we go here and we look at our method, in the side milling, we can go see what that is set to. You can see that's set to 0. Down here, let me pause this for a second. You see at the root level of the method, you have this option, keep associativity with default values. With that selected, because the value in this operation is the same as the default value, we've not modified it, it's going to be associative to that default value should we change it in the defaults. So let's go look at how this works. So now we're going to apply this method, I believe. Nope, we're going to look at default values. Let's make this default value current. And then we'll go look at the side milling stock to leave again. Here you see the new default value is 0.2 millimeters. Okay, the one at the bottom is 0.3. Cool. So we execute this. And then if we look at the side milling operation here, notice it's 0.2. And the reason it's 0.2 is because our method was set to be related to the default values. If we go change our default values, and we execute the exact same method, now they'll all be at 0.3. And of course, if we modified the method and deselected that keep associativity with default values, then it will keep whatever we have set in the method. It's not associative back to the default values. Alrighty. All right, so the next example has to do with an improvement for searching geometry for breaking edges milling. Okay, in the method, we add a new function to search geometry to find breaking edges. So here we go. Here's our find breaking edges. You can see that in here, you have all of the same filters and whatnot you're used to seeing in the breaking edges command. That's where you go and add it from. And like this, then you can actually create a breaking edges methodology. Okay, fast forward some of this. Again, most of it is standard methods stuff. So if we go here now and we just drag and drop this in, hit go. Wants us to pick a point for the Z minimum. It's got our previously selected point, which is fine. Pick that point, who cares? And then it is going to calculate all the edge breaking for us. Just like that. Perfect. Okay, moving right along. I have a few more points on methods, and then we will move on to some miscellaneous things. So the next point has to do with analyzing element length. In a general method in the analyze element function, a length variable has been added. Okay, this way it returns a length of a 2D or 3D profile, a segment, an arc, a spline, an ellipse, an edge given by the action fields find elements or picking elements. So it's just a way for you to pass a measurement based on analyzing any of those objects. There we go. Let's have a quick look. So we can select an element. There's a spline. And here we're just, again, making a dialog box to show you the passing of that information. Okay. It's nothing exciting, but maybe you want to use that as a way to filter to find the right tool length. Who knows? Okay, so you have the ability now to measure for those things. All right, next improvement has to do with radius management. The goal of this is to allow the user to create fillets in general and drilling methods in order to select the correct method in cylinder analysis. Let's have a look. So let's go ahead to drilling. We can add a fillet even. And again, the purpose of the fillet is so that we're analyzing geometry properly. If there's a fillet on the hole, we want to be able to measure that way. It can be at the top or the bottom of a cylinder, by the way. Same thing with the general purpose methodology. So we'll go to hole creation and you will see here, cylinder, and then you'll see the fillet command there so that you can put a fillet at the top, at the bottom, however you want, so that you can, again, analyze for that. Let's fast forward some of that. Perfect. So here we're looking for this diameter. Maybe you want to measure off that top diameter. Just giving you more analysis tools to make better methodologies. Okay, next one is analyze manufacturing features for drilling or end milling. So in the general method, we had two new functions to analyze manufacturing features, the analysis of drillings and the analysis for end millings. Okay, so these two objects are specifically for analyzing manufacturing features. Again, if you're not familiar with manufacturing features, we're going to hold a webinar soon to discuss those in depth. Once you have the analysis, of course, then you have the ability to pass information to other areas within your methodology. Same thing with millings. Okay. So now if we go and analyze, here's our machining features, or manufacturing features. And now we can go and look at machining them. So here, again, we're using the dialog box as just a way to show you it's pulling the information out of there. Normally you would use this probably to go and find or apply the specific toolpath for those specific manufacturing features. Okay. Next point, adding a fixture in end milling and side milling. So we have picking of elements. So we have our face to machine, for example. Another picking of elements, select face for side milling. Another element, select shapes for fixtures. And then inside of end milling, miscellaneous geometry, fixtures is now the results of picking element 3, the fixtures. Okay, same thing with side milling. So the improvement here now is that you can pass fixture selection objects into end milling and side milling. So if we go and execute this methodology, here we go. That's the face we want to face off. That's the face we want to side mill. Why not? These are the solids for the fixtures. Perfect. And there you go. Nice clean methodology. All right, last one for methods is this. In the method, we have added a variable Medot depth tapping. Okay. And more importantly, we'll show you. So there's the Medot depth tapping, but if you go to tool, you have the tap depth. Depth tapping. So this way you can run tests on it, against it, use to calculate, you can do whatever. Okay. Perfect. Okay, that's it on method improvements. All right, so now we're going to get into some miscellaneous stuff. First one is right here. So in some cases, you need to do some machinings on a weldment or something like this, right? So if I run the simulation on this one, we need to be able to come in there, we need to be able to do our machining. Off we go, right? Now, the problem is when you go to do a machining on a weldment like this, remember, TopSolid looks to the highest altitude in that direction of machining, so it sees everything over here. So it makes or sees many intersections or things like that. So for example, I'm going to show you how to machine this pocket. And this is a new feature that exists. So if I select that face and I go to end milling, okay, first it's putting us back in the 0 home position. Let's solve that first. I believe we want that position like so. So we'll set that WCS. Then in the geometry tab is the new command. There's a new command in here called tool holder is in the part. It's saying that accept the fact that we're going to be inside the part with the holder. So now it's not going to look at the altitude all the way out to here. Because of that, we need a free plane altitude. So for example, I'm going to go to a point. Maybe that point will be right there. Okay. And then we can click OK. And if we look now, we have toolpath. About the only thing that we still have to deal with is, of course, the link movement. It's very hard for the software to determine what it needs to do here, but this is why we have a link movement editor, as well as this is an excellent example of link movement editing. So we'll take this moment to kind of do a deep dive into this one. So we have this part, and I'm going to minimize this over to the side. This is where the tool's coming from. We need to safely get over to there, okay? If I follow the automatic one, it's rotating like so, then it's doing this, then it's doing this, and well, all sorts of bad things. So let's go to manual. Let's wipe everything out. Okay. First thing I want to do, I want to make a safe movement for my tool, get it out of the weldment. So I'm going to do a movement to coordinates, and I'm going to, in Z, go to change tool. Notice that when I click this, it just rapided right through the center of my weldment because we're in WCS. Remember, we're coming from this last operation. I don't want to be WCS, I want to be based off my machine coordinate system. So one of the significant differences here. So I just want, no matter the orientation of my tool, I just want to go back to the 0 in Z on the machine coordinate system. From here now, I'm going to insert another movement. This movement is going to be based off the origin because I'm going to command the end rotations of the rotary axes. I want all of them to get to their end position. After that, I'm going to do another movement to coordinates. And at this moment, I'm going to calculate an output based on the WCS. Remember, WCS stands for work coordinate system. It is the rotated coordinate system. Now, I want to think of my Z-axis relative to that rotated coordinate system, right? So that's why we're in work coordinate system. So I can go to ending like so. And a quick power user trick for you, if you just click anywhere in this white box, then you can hit Control-C, Control-V to make a copy of it. And here I'm going to go ending, ending, and X and Y as well. Okay, so now we've created a very, very clean movement. We've used the new function to allow us to machine inside the part like that. And if we go and watch this simulation, let's do it this way so the rapids are fast. All right, get to the end here. So now there's our Z retract. We rotate the B or the A or for whatever it is on this machine. We come back in and we do our machining. Cool. So nice new improvement. Okay, the next new improvement is Machinable Property. This one is actually extremely cool, albeit it's a boring example. So let's go here to make a machine document real quick. So there's a new property type, is machinable part, okay? So I believe I already have it in here, but let's delete that. And then we can go to construction, parameters, and where's what I'm looking for? End of day brain fart. I don't think it's a user property. No, it is machinable. Okay, so is machinable is what we want. Okay, so if this is machinable, we want this to be true or false. False. So we're going to say this is true. This is machinable. So we're going to leave it at true. And now, what does this all mean? If there's a property set, if the is machinable property is set to true, if I drag and drop this in, I'm going to get this dialog. Okay. This dialog where it says, is this an NC part creation? Is this an inclusion? If it's set to false, I just go straight to positioning. TopSolid'Cam no longer looks at this as a possible machinable part. So for all your fixturing out there, you can define the is machinable property to false on all of them, and it just saves some clicking. Okay, that's that. Okay, next, and I'm going to show this one in a video because we have a nice video for this. This is 14.3. Okay. So, real quick, what you're seeing in this video, on the left is version 7.14, on the right is 7.15. Both have the show machine preview and position active. When it's active, it's hard to select things. So you have to go and turn it off again. Watch what I mean. So here we're going to show you really quickly that this is show machine preview and position is active. Again, that's 714. Here's 715. Show machine preview is active. It's the same project, just in 715 versus 14. Okay. If we go into 714, we hit our little plus sign and we say to select some edges. Notice it's hard to select edges, right? Because the part is rotated. When we go to edge profile here, notice it turns off temporarily the rotation of the part so that it's back in its natural form so that you can go and select edges. Can I full screen the video? Sure. Do you want me to rerun the video? All right, I'll rerun this one. All right, so again, 714 on the left, 715 on the right. We're going to show you that both have show preview and position active in the operation. The improvement has to do with when you need to go select geometry, when you hit the plus sign in the geometry options. In 714 and prior, when you do this, the part stays rotated. So it's hard to select things because it's not in the good position. In 715, when you do that, notice it turns off temporarily the rotation of the part. So it's back in its neutral format or neutral position so that you can select edges more easily. That's it. That's the improvement on that one. Alrighty. All right, so the next one is another video. This one has to do with the shop floor document showing the proper environment with the right stock model. Okay, so here just showing you in my template that we have environment activated. And now if we go ahead, there's my template for it. Now if we go ahead and just make a quick setup sheet for this, and we'll choose that template. There is op 10, for example, and there's op 20. So it's automatically showing the two setups. Now, these are also in the same CAM file. It's super important to understand. You can't get both of those automatically from one drawing unless they were both in the same CAM file. Okay, next, and we'll do this one live because it's fun. Global fitting. So, if you guys were watching the design news, there was a couple of new design tools that we were labeling as CAD for CAM. So we're going to go ahead and show you them live, how they work. So I'm going to go ahead and delete that. Switch back to CAD mode. We'll delete the fitting shape. There's a bunch of different ways to go about doing this. I'm just going to show you one of them. So I'm going to go start a 3D sketch, right? And I'm going to go create multiple intersections. To begin with, I need some edges. So I might as well, or pardon me, some faces. So I'm going to do faces by color. And select those faces there. Then I need some guide curves. I did not create them ahead of time, so I'm going to create them on the fly. I'll just say edges profile. That's the first one. Notice the direction of the vector, that's important. Edge profile for the bottom. Okay, right now they're not facing the same direction, so make sure they face the same direction. And then from here, you can play with, if you're on this mode, the number of sections you want. Maybe I want 10 only. Okay, you don't want to go crazy. You don't necessarily need to go, real high on this, but you want enough so that it can recreate all of those surfaces as one clean surface relatively cleanly. Okay, so I'm going to go with 45 and click OK. So there is my sections. From there, I go to my surface tab And right here is the fitting surface command. So I'm going to select that surface. A really, really cool feature of fitting surface has to do with this right here, and it's minimized by default. So guys, remember to take a look at some of these minimized sub functions, because you look here, we're not quite getting all the way to the edge of the part. So why not extend it a little bit? How's that for nice and clean? Then you have one perfect surface. Let's hide the sketch. There's your clean surface. And now let's just go ahead and machine it. So I'm just going to machine this using sweeping. Okay, I'll just accept the defaults. It's good enough for me. And then we can take a look at the actual toolpath, and you can see that that is perfectly smooth, wonderful toolpath. Whether you're using it for 5-axis or 3-axis or 4-axis or whatever, it's just a handy little surfacing tool to clean things up. Alrighty. All right, next point, adding detailing or cuts on the tool list. And let me show you what I'm talking about here. On my tool list, I want to have stuff like this. I want to have details show up in my tool list. Why not? So let's watch the video on how to do that. All right, so we have our operations. Okay, so first of all, standard operation list, right? But we'd like to make it a little more obvious to our operators what's what. So we're going to copy and paste this. Okay, so now let's move our detail view over, and then we can go to Sketch, and we're going to make a new auxiliary model view. This is going to be a detail view or a cross-section view or an auxiliary view. The reference view is going to be that view. And then we're going to pick where we want to put this. Perfect. Okay, from here, we save. Check in. And let's see what this does for us. So that was the start. Now we're going to go to the finish, the one we just worked on. And there you go. So super simple, gives good detail information about each of the tools in use. So, but this is what you should ask yourself. How does it work? Because it's nothing in life is that easy, right? So we have to take a look at our tools. Yeah. So in your tools, you have a draft attached to the tool family. And it's in that drafting document that you have detail views defined. Then we use that and map it automatically for you. So you simply have to create your own detail view from your family or from your independent tool, if it's an independent tool. Okay. And you go and create this as predefined views. Once that's done, then they will show up always So here we can do another one. Okay. So now that we added a second one, now it's of that instead. But if you want both views or even more, you have them activated and you name your views. Okay, shank and cutter, for example. And now when you run it, actually I think we have to add one more of those to it. So we come into here. And you call your predefined view name. So when you're editing it, you now define it by name. You add another auxiliary view. Make sure you update the name of the auxiliary view to shank or whatever it is you call it. And then that's it. You adjust, and now when you run it, you see you get both. So there's some work to be done, but once it's done, and you have a very nice setup sheet. Cool. Okie doke. Last miscellaneous thing is an interface with Mako. Fast forward this a little bit. And what is this Mako thing doing? I forget already. Oh, it's for the Vericut simulation software that is manufactured by CG Tech, was adapted by Safeguard, and it is put into the controllers of Mako machines. So this little add-on, if you have that, allows you to pass information into that machine. Okay, so I would say the thing to know here is if you have a Mako and you have the built-in verification, reach out to us and we can help you with this prospect. Okay. But here, we'll fast forward this a little bit. I don't know if there's a simulator of it. I don't think there is. But it's passing along all the information required so that at the control, your operator on your Mako can run the verification. I don't think there's a picture of it at the end. No. This is just our side of the interface. Okay. I believe that is it. So that is the end of the What's New with TopSolid'Cam. Tomorrow is, like I said, it's more design related for mold design and die design. So if there's any of you out there that are going to look into that, we'll see you tomorrow. If anyone has any other questions, can hang out here for a few seconds, see if anyone has anything else. Otherwise, we appreciate you all taking time to stick with us live. All these videos will be available next week on the YouTube channel. We'll shoot out an email about that then. All right, have a great afternoon, everyone.